All right, we're going to look at two more examples of integration by parts, and then we're going to move along to something else. So first we're going to look at the integral of x squared cosine x dx. This one's going to behave pretty much like those power functions times e to the x that we saw before. So I'm going to let u be the monomial part, x squared, and I'm going to let dv be cosine x dx. Differential of x squared, pretty straightforward. Du is 2x dx. Where we have to be careful and take our time is when we're integrating sine x or cosine x, because we want to make sure that we have the sign correct. I think most of us can remember that the derivative of sine is cosine and the derivative of cosine is negative sine, but oftentimes when we're integrating sine or cosine, we get a little bit mixed up with those negative signs. So integral of cosine is positive sine x. So our v is equal to sine x. So applying my integration by parts formula, the integral of u dv is equal to u times v, so x squared sine x minus the integral of v du, which I'm going to write as 2x times sine x dx. So now we have to integrate by parts again. Again, I'm going to let my u be the monomial part, and I'm going to let dv be the trig part. I could have paired the two with either one, it doesn't make a difference. So my du here is 2dx, and my v, well, the integral of sine is negative cosine, right? Because the derivative of cosine is negative sine. So we want to be careful about that negative. All right, so now I can write my integral now up here as x squared sine x minus, I want to make sure I'm subtracting this entire thing, integral of u dv is equal to u times v, which I'm going to write as negative 2x cosine x minus the integral of v du, which I'm going to write as negative 2 cosine x dx. Before I even think about integrating that, I want to simplify some of these negatives. Actually, all of these. So I'm looking at x squared sine x minus negative 2x cosine x gives us plus 2x cosine x. And then I'm looking at minus, minus, minus. So three negatives there. So that's going to be minus the integral of 2 cosine x dx. And now that's simple, and so we have x squared sine x plus 2x cosine x, and the antiderivative of cosine is positive sine, so minus 2 sine x, and finally we're going to add our plus c. So that's a pretty simple example. The last one we're going to do is probably the trickiest type of problem that you'll see with integration by parts. And that's the case where we have a product of two functions, neither of which disappears after repeated differentiation, right? No matter how many times I differentiate or integrate e to the x, it's going to be e to the x. No matter how many times I differentiate or integrate cosine 2x, it's going to be sine or cosine of 2x up to a constant multiple. All right, so Because of that, our first choice of u and dv don't really make that big of a difference as long as we stay consistent throughout the entire problem. Now, remember, the tricky thing about this last problem was making sure we got the negative signs correct when we were integrating our sines and cosines, so that I don't have to worry about that as much. It's easier for me to remember my negatives when I'm differentiating sine or cosine than it is when I'm integrating. So I'm going to choose my u to be the cosine 2x part. And integrating e to the x dx, super easy and straightforward. Okay, so when I differentiate or take the differential of cosine 2x, well, derivative of cosine is negative sine, and then we have our chain rule, so we have to multiply by the derivative of 2x, which is 2. So we're looking at negative 2 sine 2x dx. And then integrating e to the x dx, I get that my v is e to the x. So applying that the integral of u dv is equal to u times v minus the integral of v du, we have e to the x cosine 2x minus the integral of v du, which I'm going to write as negative 2 e to the x sine of 2x dx, and I'm going to simplify those negative signs. So I have e to the x cosine 2x plus the integral of 2e to the x sine of 2x dx. Now, it may not look like we really accomplished very much here. And so you may be wondering, well, why did we do that? Well, bear with me. We're going to do integration by parts again, okay? So now I'm looking at this integral. Oops, I thought I switched to purple before that. Okay, so now we're looking at this integral. Okay, so again, I'm doing a u substitution. I'm going to keep my dv as the e to the x dx part, and my u is going to be the 2 sine 2x part. I want to be consistent with what I call my u and dv, because if I had let my dv be the sine part and my u be the e to the x part, I really would just be going back right to where I was. So I want to be consistent. All right, so differentiating this gives me derivative of 2 sine is 2 cosine times another 2 from the chain rule. So this gives us 4 cosine 2x dx and a v that is equal to e to the x. All right, so what I'm going to do is I'm going to rewrite my problem, and I have the integral of e to the x cosine 2x dx is equal to e to the x cosine 2x minus, and this is where we have integral of u dv is equal to u times v, so 2e to the x sine of 2x minus the integral of v du, which is equal to 4 e to the x cosine 2x dx. Let me simplify those negatives. So we see that we have the integral of e to the x cosine 2x dx is equal to e to the x cosine 2x minus 2e to the x sine of 2x, and that's going to be plus, I'm going to bring this 4 outside that integral, so plus 4 e to the x cosine 2x dx. Yeah. Oh, excuse me. That should have been a plus there, right? Because that was a plus. So let me fix those two signs. There we go. Yeah. I think I made that a minus because the last problem was a minus. Okay, so what we need to notice at this point is that on the left-hand side, we have one of these integrals. Over here, we're subtracting 4 of those integrals, and it's the value of that integral that we're actually trying to find. And so what we're going to do is we're just going to play with this algebraically, and I'm going to combine like terms. So if I move 4 of these integrals over to the left, that gives us 5 of those integrals. So I'm just left with the non-integral stuff on the right. And in order to get that integral by itself, all I have to do is divide by 5. So now I can see that the integral of e to the x cosine 2x dx is equal to, if I divide all this by 5, it's the same as multiplying by a fifth, so I'm just going to distribute that and write it as 1/5 e to the x cosine 2x plus 2/5 e to the x sine of 2x, and we need our plus c. Cool, huh?